All right, guys, this is section 1.2. We did section 1.1 on Friday, and that homework is due tomorrow. This is section 1.2. So section 1.1 was solving simple equations. This one's titled solving multi-step equations. Again, something you would have done quite a bit of last school year, but we're going to review it again. It's always good to review that before you jump into the more complex equations. And so these are the same 4 steps that we're going to use that I showed you on Friday. We're going to probably use step 1, well, definitely use step 1 more than what we did on Friday. Step 1, which says simplify each side if necessary. If necessary, it really wasn't necessary when we did simple equations, but there are 3 ways you can simplify. You can clear fractions, you can distribute, and you can combine like terms. We're going to do all of those today. And then after I simplify each side, I'm going to separate my variable term onto one side, my constant term onto the other side. I do that using addition and subtraction. And then if I have a coefficient with my x term, my variable term, if it's, for example, 3x, 5x, negative 2x, I'm going to divide or multiply to get rid of that number. And then step 4 is to plug my answer back in and check to see that it works. So let's go ahead and get started. All right, example A, negative 3x plus 1 equals 7, your basic 2-step equation here. I've got a variable term on one side, on the left side. I've also got a constant term on the left side, and then I've got a constant term on the right side. So I'm going to separate the variable and constant term that are on that left side by getting rid of that positive 1 and writing its opposite underneath of it, which means we're going to subtract 1 from both sides. And then when I do that, that's going to give me negative 3x. The positive 1 and negative 1 go away, and that's going to give me 6 on the other side. And now I'm going to divide by negative 3. And that's going to give me x equals negative 2. Okay. Now, when I write my answers, first of all, when you're doing your work paper, you need to make sure that you're writing the equation down. Okay. And if you don't want to tell me what you're doing to each side, I'm not going to force you to, because I know you guys have solved equations before. But I would at least need to see this, this, and this. If you don't write down the in-between step and you just go from negative 3x plus 1 equals 7 down to x minus 2 and you don't show any work, I cannot accept that. At least tell me that, you know, you got here, and I'll figure out that you got there by subtracting 1 from both sides. Of course, if you don't want to write that, you don't have to, but you would at least need 3 lines of paper for 3 lines on your paper for this first problem. Okay. Now, if I want to check my answer, that's a pretty simple task to do. I'm going to rewrite the original equation with negative 2 being substituted in for x. And we're going to see if it equals out. Negative 3 times negative 2 is positive 6. 6 plus 1 is 7. This equals out, so I know that negative 2 is the correct answer for x. Okay. Example B. 3x plus 5 plus 6x minus 7 equals 25. This is an example of one where I'm not just going to use addition and subtraction like I did in the previous problem, but one where I'm going to have to combine like terms. I've got more than one variable term on the left side. I've got more than one constant term on the left side. So I'm going to combine them. What's important to remember when you're combining your like terms is to remember that whatever sign is in front of the term belongs to that one. So notice how when I boxed in that 6x, I boxed it in with the plus sign in front of it to remind myself that that is a positive 6x. Okay, that's going to come in handy when I end up having negative terms and I need to use my integer rules. So 3x and 6x makes 9x. So I'm just combining my 2 variable terms into 1 variable term. Now with my constant terms, now remember constant terms are the terms that don't have a variable. Okay, so a constant is this. A coefficient is that. The coefficient is what's being multiplied to the variable term. It is part of the variable term. Okay, so 9x is my variable term, not just x. So constants are the terms that don't have a variable, and they're also like terms. They share in common the fact that they don't have a variable. So I'm going to combine this positive 5, not with a 7, that would give me 12, and that's wrong, but with a negative 7. 5 and negative 7 will give me negative 2 because I have to subtract because they have different signs. Okay, now I've got a two-step equation where I'm going to add 2 to both sides to get 9x equals 27. And now I'm going to divide both sides by 3, or by 9. I'm not sure why I said by 3. Probably because 3 is my answer. X is going to give us 3. Okay, so what is your minimum requirement of work for this problem? Write down the original problem, write down what it is when you combine like terms, write down what you get when you add 2, and write down what your answer is when you divide by 9. So this one would be 4 lines of minimum. You're welcome to write as much work as I did and show what you're doing to both sides, but at minimum, you would need 4 lines on your paper for this problem. And you should be funneling your answer down. I don't want to see anybody try to put equals and then try to write it, and then equals and try to write it. Don't be doing that. Funnel your work down for this equation. That way, when I look at the bottom of it, I see what your answer is. All right, this next one has parentheses. So this next one is one where I'm going to have to use the distributive property. Distributing is when you take a number in front of the parentheses and you multiply it to the terms inside, just like this. 3 times x is 3x, and 3 times 10 is 30. That's what distributing means. And so by doing that, it allows me to get rid of the parentheses. Now I have to get rid of the parentheses before I combine like terms. So it's really important that I do that first before I try to combine the 30 and the 6, which is clearly going to give me 36. I have to do that before, because if I do it here, that would give me 16, and that's completely wrong. So I have to distribute to get the 30 before I start combining my like terms. Then I can copy everything else down. If you're not sure what symbol goes between, ask yourself, was it positive or negative 36? It was positive, so put a plus sign. Okay. Then we're going to subtract 36 from both sides. I'm subtracting away more than what I have, so I know that my answer is going to be negative. The negative army wins this one by 24. Then I'm going to divide both sides by 3. So I can get x by itself, and that's going to give me negative 8. And if I want to check my answer, pretty simple. Rewrite the equation with negative 8 being inserted in for x, and see if it makes sense. At this point, I could distribute the 3, but since I have an x term, so I know you're looking at, well, aren't I supposed to do parentheses first? Yeah, I mean, but you can't combine x and 10 because they're not like terms. So we have to distribute the 3. Here, I can combine the negative 8 and 10 because they are like terms. And so that would give me something like this, because negative 8 plus 10 is 2. 3 times 2 is 6. And 6 plus 6 is 12. So what does that tell me? That 12 is the answer? No, it doesn't tell me that 12 is the answer. It tells me that what I plugged in, negative 8 for x, is the answer. So x equals negative 8. Here's another one where I have to combine like terms. Be careful when you're combining like terms. This is one where if you don't highlight it correctly, you might end up adding 8x and 6x to get 14x. That is not correct here. 8x and 6x would give me 14x, but this is negative 6x, which means 8x and negative 6x will give me 2x. There's nothing for me to combine the negative 25 with, so I'm going to copy the negative 25 down. Now that I've simplified, right, which is always step 1, is simplify. Now I'm going to separate. That's step 2. So simplify, separate, solve. Those are your 3 steps, and then checking is your 4th one. Simplify, separate, and solve. So I've simplified. Now I'm going to separate by adding 25 to both sides. Different signs mean subtract. Larger army wins. And then now I'm going to solve by dividing by 2. Negative 10, divided by 2, it's going to give me, and I ran out of room here, x equals negative 5. If you want to check your answer, you can again, and this is something that's optional to do, but if you're doing a quiz or test, something you probably want to do, you can double check by plugging it in either originally, or you can even plug it in right there, assuming that that 2x is correct. If I plug it in originally, I know x times -5 would give me -40. I know -6 times -5 would give me +30. And that should all give me -35. -40 and 30 gives me -10. -10 and -25 gives me -35. And I know I have the right answer. X equals -5. Okay, next one, example E. Add 9 to both sides. That's going to give me 1/2 x, or actually I might prefer to write it like this, x over 2 equals, and then -25 plus 9, different signs, subtract. Keep the sign of the larger number is going to make it -16. And then since I was timesing by half or dividing by 2, however I want to say it, the inverse of that is going to be multiplying by 2, because timesing by half and multiplying by 2 are opposites. They're inverses, they're reciprocals. I know that also dividing by 2 and multiplying by 2 are inverses. So either way, however I write it, that's what I'm going to do. And that's going to give me x equals -32. Example F. There's a number in front of the parentheses. We're going to distribute that to the terms inside the parentheses, and only the terms inside the parentheses. I'm not going to distribute it to the 4 because it's not in parentheses. So 2 times 1 is 2. 2 times -5x is -10x. Copy everything else down. Combine your like terms. You can combine this +2 with that +4 to get a +6. You can subtract both sides by 6. Same signs, keep the sign and add to get -14. And then now I have to divide by -10. Now, -10 doesn't go into -14. That doesn't necessarily mean you're wrong. It just means you're going to get a fraction or decimal answer, which is perfectly fine. I know that 2 negatives give me a positive when I'm dividing, so x is going to be positive. And I can write my answer as one of 3 different ways, actually. First of all, 14 over 10, or 14 divided by 10, is a fraction. Now, that fraction is not reduced. I would need to reduce it by 2 to 7 over 5. That's actually one way I could write my answer. 14 divided by 10 is literally 14/10, or 7/5. Or I can convert it to a mixed number. 5 goes into 7 one time with 2 left over, so I can convert it to 1 2/5. Or what some of you might do is just in your calculator do 14 divided by 10, which, by the way, dividing by 10 is just simply going to slide the decimal 1 spot backwards, and that's going to give us 1.4. And you know that 1.4 is the same as 1 2/5. So any of these 3 variations of that answer are acceptable. I just wouldn't accept 14/10 only because it's not reduced. Make sure reducing fraction or decimal answers will be just fine. Example G. -5x minus 4, parentheses -7 minus 4x equals -16. What number is in front of the parentheses? Maybe a trick question here. If you thought 4, then you'd be incorrect, because if you actually look, the term that's in front of the parentheses is a -4. Remember, the sign in front of the number belongs to that number. And that's important because if I just distributed a 4, that would give me -28. And then that would give me 4 times -4 is -16x. Okay. And that neither one of those are correct, because it's a -4. I'm actually going to get a +28 and then a +16x. So I need to make sure I'm including the sign in front. It does matter when I distribute. Then I can copy down the -5x. It was a +28, so put a plus sign. And then I can copy down the equals -16 on the other side of the equation. Now, when I combine my like terms, I've got a negative 5x right there. I've got a positive 16x right there. They have different signs. I'm going to go to war. The positive army wins this war by 11. Notice how I'm going one step at a time. So I need to show these steps on my work paper. Again, if you don't want to write minus 28 on each side, I wouldn't make you write minus 28 on each side. That's more for me just showing you what I'm doing. If you just wanted to jump straight to, let's see, negative 16 minus 28 would be negative 44, it looks like. That makes sense, considering 11 would go into that evenly. Not that it has to, but it's going to be nice that it does. And then if you don't want to write divide by 11, you don't have to. But I do need to write down that I would get x equals negative 4 as my answer. So again, the minimum work, write down the equation, write down what you get when you distribute, write down what you get when you combine like terms, write down what you get when you subtract 28, and write down what you get when you divide by 11. So these are why they're called multi-step equations, because we're not just going to do one step today. We're going to do multiple. It could be 2, 3, 4, 5 steps. To solve equations that contain fractions, multiply both sides of the equation by the LCD, which stands for least common denominator, to eliminate the fractions. That's actually one of the first steps, and the very first step you should try to do when you're simplifying is clearing fractions. Okay, so how do I do that? Well, here are the steps again. It was just one step. Multiply both sides of the equation. Wait a second, where did my, oh no, where have my numbers gone? Well, let's see. What do I want to make that? Okay, so after I found out what I had erased, I guess it was just the number 1 that was supposed to be there. So let's go and get started. So again, to clear this fraction, and by the way, I call these fractions BFFs. Probably not the BFF you're thinking of, but not best friend forever, but big fat fractions, where we have an entire side, more than just one number. It's actually 2 terms that are all being divided by 5. And so what we're going to do is we're going to clear this fraction by multiplying by the least common denominator, or really the only denominator that we have, which is the 5. So I'm going to multiply this side by 5. I'm going to multiply this side by 5. It's not as difficult as it may seem, because I don't have to distribute the 5 to anything up here, because what actually happens is multiplying by 5 cancels out the dividing by 5, and I'm just left with 14x minus 9. So it's kind of boring. Now on the other side, I am going to multiply by 5, and that's going to give us just 5. Okay. Now what I'll do is I'll add 9 to both sides. And then finally divide by 14, which is just going to give me 1. So I didn't write the in-between steps other than showing that I was going to multiply by 5 on both sides right there. So again, to clear a fraction, or in this case, a big fat fraction, multiply by the least common denominator, which was the only denominator we had, which was the 5. And so that clearing fraction step has to happen first. Okay, I can't look at that problem and say, oh, I'm just going to add 9 to both sides. I can't add 9 to both sides until it's decoupled from the dividing by 5. So I have to multiply by 5 first, use that inverse, then I can add 9 to both sides, and then it ends up giving us a nicer answer. This is one where I definitely want to clear fractions. And so what would be the least common denominator between the 6 and the 2 that I have here? And so the first multiple that 6 and 2 both have in common is 6. So what I'm going to do is I'm going to multiply the entire side. So over here, I multiply the entire side by 5. Here, I'm going to multiply the entire side by 6. And I got to do it on the right side as well. And so when I distribute that, because I'm multiplying the entire side by 6, not just one term, really what I'm doing, since I'm distributing, is I'm multiplying everything by 6. So think that 6 is going to cancel out with that dividing by 6, just leaving me 7x. Nothing to cancel out with the 2x, so this is going to give me 12x. Half of 6 is 3, so the 2 cancels out with the 6 to make 3. And that's going to give me negative 3, because it was a negative 1/2 times 6 equals 54. And so what I've just done is I've gotten rid of the fractions entirely. So now I don't have to worry about finding a common denominator. And guess what? If I was finding a common denominator and I could do it that way, my common denominator would be 6 because that's the least common denominator. And so what I can do now is do this without using any denominators. 7x and 12x is going to make 19x. Add 3 to both sides, 19x, don't forget the x there, whoops, is equal to 54 plus 3 is 57. And then if I do 57 divided by 19, I'll write down that I'm going to divide by 19 here. That would give me x is equal to 3. Okay, so again, multiplying both sides, and don't forget to do it here. Don't leave that as a 9. You have to multiply that side by 6 as well. Whew, okay, let's do another one. This again would be very difficult to do if I was using all of the fractions, but I'm going to multiply by the least common denominator. The first multiple that 9, 3, 2, and 6 all have in common is 18. 18 is a multiple of all of them. It's the lowest multiple of all of them. So I'm going to multiply, and I'm going to distribute the 18 to every term on both sides. Everything's going to get multiplied by 18 here. Okay, and so I know it looks like I'm multiplying by 18 3 times on the left side, but I'm just distributing the 18 once. So I really am just multiplying each side by 18. And so the 9 is going to cancel out with the 18, making the 18 a 2, and that's going to give me 4x times 2, which is 8x. The 3 is going to cancel out with the 18 to give me a 6. That's going to give me x times 6, or just 6x. The 2 is going to cancel out with the 18 to give me a 9. That's because 1/2 of 18 is 9. That's going to give me a minus 9. And the 6 is going to cancel out with the 18 to give me a 3, and that's going to give me equal to 33. I'm going to combine my like terms to get 14x minus 9. I'm going to add 9 to both sides. 33 plus 9 will give me 42. And then I'm going to divide by 14, and 14 plus 14 is 28, plus 14 is 42, so it goes in 3 times. And so x is equal to 3. So clearing fractions. Now, it's not stated that you can clear decimals up in the rules, but since decimals can be written as fractions, you can also clear decimals. Clearing decimals is actually easier to do. Here's the problem I'm referring to. Just notice, first of all, they all have 1 decimal place. So all I have to do is slide the decimal point over 1 spot on every single term. And now I've gotten rid of the decimals, and I don't have to work with them anymore. Now, why am I allowed to do that? Because what I'm doing is distributing a 10 to both sides. I'm timesing everything by 10, which is why I'm allowed to slide the decimal over 1 spot. So 11x plus 12x, 1.1 times 10 is 11, 1.2 times 10 is 12, 5.4 times 10 is 54, it's negative, and then negative 10 times 10 is going to be negative 100. And now I've gotten rid of the decimals. If you want to, I mean, you could still do it with decimals using your calculator. Heck, you could still use fractions if you wanted to. You don't have to clear them, but I would suggest to do so. Combining your like terms, the 11x and 12x are going to give you 23x. Add 54 to both sides. 100 plus 54 should give us 46 negative. Negative 100, I'm adding 54, so it should be negative 46. And then I'm going to divide by 23. And when I divide by 23, 23 goes into 46 twice. So it's going to go to negative 46, negative twice, and that's going to give me negative 2. Let's look at a story problem. The height in feet of a fig tree, I'm not sure where I got fig, of a tree after y years is 1.5y plus 15. After how many years is the tree 24 feet tall? Well, they've already given me the expression. It grows 1.5 feet per year. So that's what the 1.5y would tell me, that every year it's going to get another 1.5 feet taller. When they planted it, it must have already been 15 feet tall because you're starting with 15. So add 15 to that 1.5 feet per year. And altogether, it wants to know how many feet it'll be how many years, not how many feet, how many years will it take to get to 24 feet tall? And so the first thing you would do is subtract the 15 feet you started with, because if the tree was already 15 feet tall to start with, that means you only need it to grow 9 more feet. And if it grows 1.5 feet per year, divide by 1.5 to see how many 1.5s go into 9. And you'll find out that it goes in 6 times, so it'll take 6 years. Don't forget to label your answer on a story problem. We were talking about years, so it'll take 6 years for that tree to grow to 24 feet tall because it's already 15 feet tall. Here's another one. Use the table to find the number of miles X. So X represents miles. I would have used M, but I guess they're using X here. You need to run Friday so that the mean number of miles run per day is 1.5. So you're trying to get an average or a mean of 1.5 miles. And so you ran 2 miles on Monday. You didn't run Tuesday at all. You ran 1.5 on Wednesday. You didn't run Thursday. Now how many miles do you have to run Friday so that your average for those 5 days would be 1.5? And so how do you find average? Well, you add up all the numbers you have. So Monday plus Tuesday, 0, plus Wednesday, plus Thursday, 0, plus Friday, all divided by the number of days. Now it looks like I've only got 3 days here, but I have to include all 5 of them because the zeros do count. So I'm going to divide that by 5. And now what do I want my average to be? Because that's how I find average. I want my average to be 1.5. So we have here a big fat fraction. What I'm going to do is I'm going to clear that fraction by multiplying both sides by 5. So all that's going to do on this side is cancel out with the 5. And so I'm really left with just 2 plus 1.5 plus X is equal to, and then 1.5 times 5. I want to say that's 7.5. Yes, it is 7.5. Now I'm going to combine my like terms. The 2 and the 1.5 give me 3.5. So 3.5 represents the total number of miles I ran for that week on Monday and Wednesday are the only 2 days I run. If you take those 2 away, so we're going to subtract 3.5, that means I need to run 4 miles on Friday so that my average would be 1.5. And why do I have to run so much on Friday? Because I didn't run Tuesday and I didn't run Thursday. That would be why. So how do I set up that equation again? I started by writing down all 5 numbers, except I didn't write down the zeros because adding 0 doesn't do anything. Dividing by 5 and saying, I want that to equal 1.5 for my average. And that is how I set that equation up. And I just solving using clearing that fraction and combining my like terms. All right, our last problem here says TJ and Isaiah went to rent sports equipment at the city park. TJ rented inline skates and Isaiah rented a motor scooter. The inline skates are $3 plus $1.50 per hour, and the motor scooter is $10 plus $2.75 per hour. They were both at the park for the same amount of time. If their total rent cost was $38.50, for how many hours did they rent the equipment? So just get us back in the groove of defining what our variable is. It says in that last sentence, for how many hours? So I'm going to use H, although you could use whatever letter you want to, but it does have to represent the hours spent at the park. And that's a combination of both of their hours. I mean, well, it's not a combination of their hours. It's this price is a combination of their equipment they rented, but they both stayed at the same amount of time, it says. And so they both stayed for the same amount of hours. So how are we going to write this equation? Well, TJ rented the inline skates. And so he's going to pay $3 for those inline skates plus $1.50 per hour. So times number of hours. Now, when it says their total cost, that means if you add up everything they spent. So I'm going to add that with the amount of money that Isaiah spent, which was $10 plus $2.75 per hour. And that's going to give us a total of $38.50. Now, do you see decimals? I do. You can work with those decimals. That's fine. It probably would take you the same amount of time. Or since The most number of decimal places I see is 2. You could slide all the decimal points over 2. And if it means that much to you, you wouldn't have to work with any decimals at all. You could do that, or you could leave the decimals and just do it the normal way because you have a calculator and it's really not that big of a deal. When you combine your like terms, you get that for the constant term. For your variable term, you should get, let's see, the 150 and 275 should be 525, or $5.25 total if you're using decimals. Okay, I'm going to subtract here, use my calculator. I'm going to subtract by 1,300 or $13, depending if you're still using the decimal places. Okay, and oops, I did that wrong. 3,850 minus 1,300 should be 2,550 or $25.50. If you're still using decimals, and then divide by 525, and that would give you, whoa, that can't be right. That's what I'm getting. Interesting. Okay. That, wait a second. That's not the same answer I just got. $4.857. I'm going to double check that because that does not seem like it would be right. Did I move this over twice on each one? $3 plus 150, $10 plus 275. Yes, 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 yes. Okay, I wonder if my math is off here. Let me check the 150 plus the 275. Ah, darn, that's 425. You might have caught that on your own. Sorry about that. I wonder, that just didn't look right. You might, maybe you were cringing when I said 525 because you're like, wait a second, why are you getting 525? It's 425. And that's why we should check using a calculator. And I wonder if this is going to give me a better answer. It does. When you divide by 425, you should get 6. H represented hours. We're going to label hours. Sorry about the confusion. That should have been 425 that you were dividing by. So that's going to give us 6 hours. And so I'm solving multi-step equations using these rules. If you have story problems, make sure you label using these rules right here to solve all those equations. Okay. So let me know if you have any questions. You can find 1.2 homework on big ideas, and don't forget to turn in your chapter 1 openers today, and 1.1 is due tomorrow.